Hello friends, in this video let us solve electronic science paper which was conducted by UGCNET in the year 2015. First time visitor, please subscribe to my channel and don't forget to turn on the bell icon to get instant notification whenever I upload a new video. Don't skip the video, I'm going to solve using shortcut method as well as procedural method. Moving on to first question, in an N-channel MOSFET shown in the figure below, threshold voltage VTH which is equals to 2 volts. The drain current of the MOSFET is 4 milliamperes. The drain resistance is 1 kilo ohms. If the value of drain current is increased to 4 kilo ohms, then the value of drain current, we know that whenever gate terminal and drain terminal are shorted, the transistor is operating in saturation region. So, transistor is operating in saturation region. What is the expression for drain current in saturation region? It is mu n times of Cox into W by L, where W by L is the aspect ratio, into VGS minus VTH the whole square whole divided by 2. So this term is a constant. I am going to call it as a beta. Because they are not talked about the values of mu n, Cox or W by L. So I can treat it as a constant. So I am having two cases. So in the first case, ID value is 4 milliampere. In the second case, I have to find. So I am going to call it as ID dash, which is equals to beta into Vg minus Vs value is 0. Vth is 2 the whole square whole divided by beta into Vg dash minus 2 the whole square. Beta and beta I can cancel. What is Vg? So Vg equals to Vd, which is equals to 10 minus of Id times of Rd. 10 minus of Id times of Rd. So I got 4 milli divided by Id dash, which is equals to 10 minus Id times of Rd. What is Id? Id equals to 4 milli into Rd value is 1 kilo. So milli and kilo is going to cancel. That is 4 minus 2 the whole square whole divided by 10 minus what is the value of ID? ID we don't know, so I'm going to call it as ID dash into what is the value of RD? It is 4 kilo. Now look at over here, current is in the order of milliamperes, resistance is in the order of kiloamperes. No need to write explicitly as milli and kilo minus 2 the whole square. So on cross multiplying, what I will be getting is this entire term value is 10 minus 4 is 6, 6 minus 2 will be 4. So I will be getting 4 divided by ID dash, which is equals to 4 square divided by what is 10 minus 2? It is 8 minus 4 ID dash the whole square. So square and 4 is going to get cancelled. So what I will be getting is 4 times of ID dash, which is equals to 8 8s are 64, nothing but a minus b the whole square, plus 16 times of id dash minus 64 times of id dash. So finally what I will be getting is 16 times of id dash square minus 68 times of id dash plus 64, which is equals to 0. So on dividing, what I will be getting is 4 times of id dash square minus 17 times of id dash plus 16, which is equals to 0. With the help of minus b plus or minus under root of b square minus 4ac, what I will be getting is id dash, which is equals to 2.802 milliamperes and 1.396 milliampere. Able to follow? So I need to opt for 1.396, nothing but 1.4 milliamperes. Why I have to opt for this one? Why should I not opt for 2.8? What is 2.8 multiplied by 4? It is more than 10 volts, so it can't be. So the suitable option that is going to follow is option C is going to follow. The other way of solving, I'll be explaining at the end of the video. Second question, in an NPN diffuse junction transistor, the p-type base region is formed on the n-type collector region through the process of allowing epitaxial layer growth, diffusion of p-type of impurity, change of nature of doping during crystal growth. It is achieved through the process of diffusion of p-type of impurity, nothing but option 3 is going to follow. Given the waveform, you have to calculate the average value of the periodic trapezoidal waveform. In order to calculate the average voltage, V average, which is given by 1 by 2 pi times of the area what is the area? Now look at over here, this one I can treat it as a rectangle. So in the rectangle I will be having length and breadth. What is 4 pi by 3 minus 2 pi by 3? It is 2 pi by 3 into what is the length? It is Vm, plus here you are having one triangle, here you are having the same triangle which are similar. So I am going to superimpose over here. So what I will be getting is 2 pi minus 4 pi by 3, that is again 2 pi by 3 into what is the value of the length? Length equals to, so I will be getting 4 pi by 3 into 2 pi. So I will be getting 2 by 3 times of Vm, nothing but option A is going to follow. I have solved this question based on area property. Now look at over here, this is my time period, that is t. After each successive time period, the waveform is going to repeat. Fourth question, in the circuit shown below, it will act like an ideal current source with respect to the terminals A and B when frequency is. Whenever the source, if I am treating it as an ideal source, especially the current source, you will be having a current source. In parallel to this, you will be having an impedance. That impedance is an infinite value in the case of ideal current source. So in the case of ideal current source, the resistance offered over here is infinite, but in the case of practical scenario, the resistance will be in the order of mega ohms. Now look at over here, this term I want to be an infinite value. So how can I find is, we know that resonant frequency Fr, which is given by 1 divided by 2 pi under root LC. At what frequency this one will resonate? So I have to express in terms of radians per second. What is 2 pi times of Fr? It is omega r, which is equals to 1 divided by root LC. What is the value of L? It is 1 divided by 16. What is the value of C? It is 1. So I will be getting 4 radians per second, nothing but option D is going to follow. Or there is one more method to solve. Now look over here, I am having this inductor. This inductor, if I am taking a Laplace transform, what I will be getting is 1 by 16 times of S. And for the capacitor, what is the Laplace transform? It is 1 divided by S. And the voltage source, I am going to assume it as a short circuit. Now what is the impedance looking at this end? Because I want that impedance to be an infinite value. To make impedance an infinite value, let me take a Laplace transform. So what I will be getting is S divided by 16 into, it is in parallel with this, right? So it is 1 divided by S whole divided by S by 16 plus 1 by S. So I will be getting S divided by S square plus 16. This term I want to be 0. So I am equating S square plus 16, which is equals to 0. That is S equals to plus or minus J4. So just J4 is plus or minus J times of omega n, which is natural frequency of oscillation, nothing but I am getting option 4 as correct answer. Moving on to fifth question, in a certain oscillator they have given gain, nothing but forward gain equals to 50. The attenuation of the feedback must be, they are asking. We know that according to Barkhausen criteria, A beta should be equals to 1. What is the value of feedback factor? That is beta, which is equals to 1 divided by AV, nothing but forward loop gain, which is equals to 1 divided by 50, that is 0.02. That is 0.02. Nothing but option 4 is going to follow. We know that practical value of the Barkhausen criteria should be A beta is approximately equals to 1.02 or slightly greater than 1. This concept is also very important. Sixth question, in a circuit shown in figure, if input voltage VA equals to 0.2 volts, then the output voltage V0 equals to, they are asking. We know that these two configurations are inverting based configurations that are connected in cascade form. Let me call this resistance as RF2 and this resistance to be Rin2, and I am going to call this 50 kilo ohms as RF1 and 10 kilo ohms as Rin1. So what I will be getting V0. V0 equals to, let me call this intermediate node voltage as V01. V0 equals to minus RF2 divided by Rin2 into V01. Now what is the value of V01? So I will be getting minus RF2 divided by Rin2 into, what is V01? It is minus RF1 divided by R in 1 into V in or Vi. So minus into minus, it is going to get cancelled. So what is the value of RF2? It is 150K divided by R in 2 is 25K multiplied by 50K divided by 10K into 0.2. So it is 10 ones are 5s are 25 ones are 25 6 are 6 5s are 30 30 into 2s are it is 6 volts. Seventh question, which of the following A to D converter is fastest? We know that we are having 4 A to D converters. First one is counter type, second one is flash converter, third one is successive approximation register type, fourth one is dual slope or integrating type. We know that the conversion time in a case of flash type, it is 1 times of T clock, nothing but only 1 clock cycle is more than enough, which is approximately few nanoseconds. So the speed will be very high value. Similarly, if I am talking about successive approximation register type, it is n times of T clock. But if I am talking about dual slope or integrating type, it is 2 power n plus 1 times of T clock, which is very high value. Hence, we are not going to prefer dual slope when I want A to D converter to be a fastest one. At that time, I will be going for successive approximation register type. Why I am not going to prefer flash converter? Because we are in need of 2 power n minus 1 times of comparators. So the circuit is complex. Hence, we are not going to prefer flash converter. When we are going to prefer dual slope? If you want high accuracy and high precision, and if you want to overcome the effect, at the time you are going to make use of dual slope or integrating type. Especially it is used in digital multimeter or digital voltmeter. Moving on to 8th question, for wire and connection we make use of TTL gates without active pull-up and with open collector. In the case of 8085 assembly language instruction that stores the contents of HL, so HL is a register pair into the memory location, that is 2051H and 2050H respectively. How you are going to store is SHLD 2050H. So this 2050 location and 2051 location will be accessed by H and L register pair. So this is a single block of memory. Consider the following statements of 8085 microprocessor. Which of these causes the change in the status flags? First one, move M, A. Nothing but you are performing move operation. Move immediate A, FF. These two instructions will not alter the status of flags. If I am performing compare M, what it is going to do is A minus M, nothing but accumulated data minus memory data it is going to perform, and status flag will get affected. Say suppose if I am performing SUB M, what it is going to perform is A minus M, it is going to assign to A as well as flags will get affected. Here compare means it is virtual subtraction. So the suitable option that is going to follow is option 2 is going to follow. 11th question, a member of a structure object can be accessed through a pointer to the structure object by using arrow operator, that is this one. 12th question, the value written by string length when a string instruction that is constant is given to it as an argument. Suppose if you want to save UGC. So if you are saving this string memory that is UGC, at last it will be ended with a null character. But if I want to calculate the length of the string, it is not going to include null character. So it is same as the number of characters in the string argument, nothing but option 2 is going to follow. Moving on to 13th question, it is based on EMTL. For a quarter wave ideal transmission line of the characteristic impedance that is 50 ohms. So they have given characteristic impedance equals to 50 ohms and the load impedance they have given 100 ohm. What is the value of input impedance they are asking? We know that input impedance which is given by Z0 square divided by ZL, which is equals to 50 square divided by 100, that is equals to 25 ohm, nothing but option 2 is going to follow. 14th question, a transverse electromagnetic wave impinges obliquely on a dielectric to dielectric boundary with epsilon r1 equals to 2 of one of the medium and epsilon r2 equals to 1 of another medium, the value of the angle of incidence for total internal reflection they are asking. We know that the angle of incidence, that is sin theta I at total internal reflection, which is given by under root of epsilon r2 divided by epsilon r1, which is equals to 1 divided by root 2. So I got theta it, which is equals to sin inverse of under root of 1 by 2, which is equals to 45 degree. So sin 45 is 1 by root 2. So the option that is going to follow is 1. So 15th question is based on power spectral density. The power signal f of t as a power spectral density defined by sf of omega, which is equals to n divided by a square. For omega less than beta, the power spectral density of df of t divided by dt will be, it is omega square n divided by a square. So you should know differentiation property, you should know convolution property, you should know multiplicative property, all those property you should know, time shifting, time reversal, then only you can solve this kind of problems. Moving on to 16th question, the Rayleigh distribution of a random variable x is defined as, we know that it is defined as fx of x, which is equals to x divided by sigma square into e power of minus x square divided by 2 sigma square when x is greater than or equals to 0, fx of x equals to 0 otherwise. 17th question, the fiber has a core radius of 6 micrometer and is operating at a operating wavelength of 1550 nanometer. The V number is given by, we know that in the case of optical fiber, V number is given by 2 pi a divided by lambda into numerical aperture, nothing but 2 pi a divided by lambda into, what is numerical aperture? That is core refractive index square minus cladding refractive index square. So they have not talked about core refractive index as well as cladding refractive index. So this formula you can't apply. But we know that in the case of single mode fiber, V number is less than or equals to 2.405. Hence you have to opt for option 4. 18th question is based on voltage safety factor of a thyristor. Voltage safety factor of a thyristor is given by Vf, which is equals to V peak inverse voltage divided by root 2 times of RMS value of operating voltage. Also you have to remember the peak inverse voltage of half wave rectifier, full wave rectifier as well as bridge rectifier. These things are very important. And you should also know what is the significance of this peak inverse voltage. 19th question, which of the following is used to estimate the probable error of any instrument? It is with the help of Gaussian distribution. It is with the help of Gaussian distribution, nothing but option D is going to follow. Moving on to 20th question, the circuit diagram of a capacitive transducer is shown in the figure. Now they are asking what is the value of E0 and what is the curve. We know that the capacitor will be behaving like an open circuit or short circuit whenever the frequency is a low value or a frequency is a high value. When frequency is a low value, nothing but approximately equals to 0, the capacitor will behave like an open circuit. At high frequency, the capacitor will behave like a short circuit, because Xc is given by 1 divided by omega c, which is equals to 1 divided by 2 pi fc. In the first case, let me take f equals to 0. So if I am taking f equals to 0, I'll be getting this capacitance value as open circuit. So I'll be having a resistor over here and I'll be having a battery, that is EP, and the capacitor is behaving like an open circuit. So in this open circuit, current will not flow. So current is approximately equals to 0. So E0 is approximately equals to 0. But as frequency increases, the capacitive reactance behaves like a short circuit, or the resistance offered by it gradually decreases. So when it is gradually decreasing, E0 term will be increasing, that is E0 divided by X. Nothing but option 2 is going to follow. Which of the following statements are valid for JFETs? The drain to source current, which is given by drain to source saturation current into 1 minus of VGS divided by VP. This statement is false. Second statement is also false. Mu equals to Gm times of Rd is correct, but none of the option is getting followed. But they have made a simple mistake while printing. It is 1 minus of Vgs divided by Vp the whole square, then it will be correct. So if you are making small assumptions and you are solving, statement A and statement D is correct, nothing but option 2 is going to follow. 22nd question, which of the following statements are true for a Zener diode? So in the Zener diode, voltage across the Zener resistance is 0. It is a wrong value. In the case of Zener diode, the threshold voltage is 0.7 volts. The diode is used as a constant voltage device. Yes, you can use the diode as a constant voltage device only when it is reverse bias. Only when it is reverse bias, it will be acting like an voltage regulator. The diode is used as varactor diode is wrong. The diode is formed by heavily doping the P and N type semiconductor. You have to make a suitable assumptions and then you have to solve for the question. So statement B and D is going to follow, nothing but option 2 is correct. So while framing question, so they have made a simple mistake. Instead of writing N, they have written it as P. Moving on to 23rd question, H parameters can be obtained in terms of Z and Y parameters. Following statements have been given. You have to identify H parameters in terms of Z and Y parameters. If you are remembering the conversion, it is well and good. If not, on spot you have to derive the expression. Now, what they are given is, they have given H parameters. In the case of H parameters, V1 and I2 are dependent variable. So how can I express V1 as it is H11 times of I1 plus H12 times of V2. Similarly, I2 is given by H21 times of I1 plus H22 times of V2. I am going to call this one as equation 1 and this one as equation 2. Now look over here, I want to express in terms of Z parameters. So in the case of Z parameters, V1 and V2 are dependent variable. How can I express Z11 I1 plus Z12 I2? Similarly, V2 is given by Z21 I1 plus Z22 I2. So I'm going to call this one as equation 3 and I'm going to call this one as equation 4. These two are standard equations because I have to express H parameters in terms of Z and Y parameters. So if I want to express in terms of Z parameters, either this equation I have to modify in terms of V1 as a function of I1 and V2 or I2 as a function of I1 and V2. Now from equation 4, how can I write I2? I2 equals to minus Z21 I1 plus V2 whole divided by Z22 whole divided by Z22. I am going to call this one as equation 5. Now compare equation 2 with 5. Compare equation 2 with 5. So what I will be getting is H21 which is equals to minus Z21 divided by Z22 and H22 which is equals to 1 divided by Z22. Able to follow? Now what I am going to do is equation 5 in equation 3. So what I will be getting is V1 equals to Z11 I1 plus Z12 into what is the value of I2? It is minus Z21 divided by Z22 times of I1 plus V2 divided by Z22. So on taking directly LCM, what I will be getting is Z11 into Z22 times of I1 minus Z12 into Z21 times of I1 whole divided by Z22 plus Z12 into V2 divided by Z22. So what is Z11 into Z22 minus Z12 into Z21? So here I am going to take I1 as common. So upon taking I1 as common, I will be getting delta Z times of I1 divided by Z22 plus Z12 divided by Z22 times of V2. So this one is V1. So I am going to call this one as equation 6. Compare 1 with 6. So what I will be getting is H11 which is equals to delta Z divided by Z22 and H12 which is equals to Z12 divided by Z22. So on spot you have to derive and you have to get the conversion, or else you have to remember the conversions. Conversions will be bit difficult to remember. but you can search in the YouTube videos. They will be teaching you how to remember the shortcuts. Now look over here, Z11 which is equals to delta Z divided by Z22, and Z12 which is equals to Z12 divided by Z22. So option A is correct. And H21 which is equals to minus Z21 divided by Z22, and H22 equals to 1 divided by Z22. So option A is correct. So I have to convert this H parameters in terms of Y parameters so that I will be getting one more option. So in order to do this, let me convert H parameters in terms of Y parameters. We know that in the case of H parameter, V1 and I2 are the dependent variables. So what I will be getting is H11 I1 plus H12 times of V2, and I2 equals to H21 I1 plus H22 V2. So I have to express now in terms of Y parameters. In the case of Y parameters, I1 and I2 are the dependent variables. So it is Y11 times of V1 plus Y12 times of V2, and I2 equals to Y21 times of V1 plus Y22 times of V2. So I am going to call this one as equation 1, this one as equation 2, I am going to call this one as equation 3, and this one as equation 4. Now I have to express these equations in terms of V1 and I2. From 3, how can I write V1 as V1 equals to I1 minus Y12 times of V2 divided by Y11 divided by Y11. So I am going to call this one as equation 5. Now compare 1 with 5. So what I will be getting is H11 which is equals to 1 divided by Y11, and H12 which is equals to minus Y12 divided by Y11. Substitute equation 5 in equation 4. So what I will be getting is I2 which is equals to Y21 into, what is the value of V1? It is I1 divided by Y11 minus Y12 divided by Y11 times of V2 plus Y22 times of V2. So what I will be getting is Y21 divided by Y11 times of I1 plus, I am writing these terms first by taking LCM. So what I will be getting is Y11 into Y22 minus this term is Y12 into this term if I am getting inside. So what I will be getting is Y21 whole divided by Y11 times of V2. So what I will be getting is I2 equals to Y21 divided by Y11 times of I1 plus delta Y divided by Y11 times of V2. So this one I am going to call it as equation 6. Now compare equation 2 with equation 6. So what I will be getting is H21 which is equals to Y21 divided by Y11, and H22 which is equals to delta Y divided by Y11. Statement A and D is correct, nothing but option 1 is going to follow. Moving on to 24th question, for the following signal x of n which is equals to half power n into u of n plus 1 by 3 power n into u of n, z transforms and ROC is given by, we know that z transforms of x of n which is given by z divided by z minus half plus z divided by z minus 1 by 3, and ROC is z greater than 1 by 3 and z greater than 1 by 2. Now look over here, if this is unit circle that is 1 by 3 and it is of half a radius, then ROC can be outside of this, or it can be inside of this, or even it can be between these points also. But ROC should not contain poles. This is very, very important. So statement A and B is correct, nothing but option 2 is going to follow. 25th question, which of the following statements are valid for an oscillator? It requires no DC supply. Let us keep this statement as aside. A phase shift around the feedback loop should be 0. Yes, you will be having a forward gain as well as you will be having a feedback path gain. Now look at over here, if amplifier is producing a phase shift of 180 degree, then the feedback also should produce a phase shift of 180 degree. To compensate for the change in phase shift, nothing but you should get 360 degree phase shift or 0 degree phase shift in the case of oscillator. If amplifier is producing a phase shift of 0 degree, then the feedback should produce a phase shift of 0 degree or it should produce a phase shift of 360 degree. So the total phase shift around the feedback loop is positive. And in the case of amplifier design, you are going to make use of negative feedback. The gain around the feedback loop should be equals to 1. Even this statement is true. The gain around the feedback loop should be less than 1. This statement is false. If they are telling the gain around the feedback loop should be slightly higher than 1, then you have to opt it. Because we know that under Barkhausen criteria, A beta should be equals to 1. But practically if I am speaking, A beta is slightly greater than 1. Is slightly greater than 1. Roughly it is around 1.02. Now they are telling it requires no DC supply. Let me consider I am having a T flip-flop that is connected in cascade. So in order to produce the oscillations, I am going to make use of toggle flip-flop or JK master slave flip-flop by giving inputs as 1 and 1. Thereby I can realize oscillator, or with the help of piezoelectric effect also I can realize the oscillation. Based on that, they are telling it requires no DC supply. The statement B and C is correct. For a full wave rectifier, which of the following statements are correct? VDC equals to 2 times of VP divided by pi or 2 times of VM divided by pi. The statement is correct. F out equals to 2 times of Fn. Now look at over here. I am plotting my input waveform with respect to time axis. I am considering my input to be a pure sinusoidal waveform. So in the case of this pure sinusoidal waveform, what will be my output in the case of full wave rectifier? In the case of full wave rectifier, I will be getting a rectified output, nothing but I will be getting either positive side of the waveforms or negative side of the waveforms, nothing but I will be getting waveforms on one side. So this is my V out waveform. You take the frequency as f over here, but here the frequency will be 2 times of f, because here the time period whatever you will be considering, here it will be t by 2. Based on this, if I am choosing, statement A and B is going to follow, but none of the options are correct. Thereby you will be getting a grace marks. So VDC is 2 times of Vm by pi and IDC is also 2 times of Im divided by pi. Able to follow? Flip-flops can be used as latches, switch bounds elimination, adder, encoder. These two options are wrong because flip-flop is a sequential circuit and adders are flip-flop is a sequential circuits. Adders and encoders are combinational circuit. Flip-flops is used to eliminate de-bounce effect, nothing but bouncing elimination switches. Yes, flip-flops are used. Now in the digital electronics, second part is sequential circuits. In the sequential circuits, first topic you will be talking about latches. So the demerits of the latches will be overcome with the help of flip-flop. We know that latches are level triggered, the flip-flops are level triggered or edge triggered. So based on this, they have told that flip-flop can be used as latches, but the disadvantages of latches is overcome with the help of flip-flop. Strictly speaking, only statement B is correct, but UGCNET board they have given statement 1 and statement 2 is correct, nothing but option 1 is going to follow. 28th question, shift register can be used as delay line, yes. Ring counter, yes. Adders, no. It can be used as a multiplier. Especially in your digital signal processing, you have studied two variants of multiplier. The first one is Brown multiplier and the second one is Bahuli multiplier. So in the case of multiplication, what you are going to do is you are going to shift by left position 1 bit. So whenever you are performing shift operation, it is multiplied by 2. Whenever you are performing right shift, it is divided by 2. So shift register can be used as a multiplier. But UGCNET board they have opted statement A and B as correct, nothing but option 2 they have opted. But strictly speaking, A, B, C should follow, nothing but option 1 should have been correct. 29th question, the instruction that clears the accumulator in the case of 8085, the first option is move immediate A, 00H, nothing but they are going to assign A equals to 00H. So this statement is correct. So logical and A and with 00, you will be getting accumulator value also 00H only, nothing but you are resetting or you are clearing the contents of accumulator. Rotate accumulator, this one is a wrong option. XOR A, yes, A XOR A is 0. So I will be getting statement A, B, D is correct, nothing but option 2 is going to follow. Moving on to 30th question, which of the following are 16-bit components? The first one what they are given is program counter in 8085, true. number of pins in 8251, it is 8 bit. Number of data pins in 8088, it is a coprocessor, it is having 8 bit component, and the data bus in 8086 is 16 bit wide, and the address bus in the case of 8086 is 20 bit wide. So statement A and D is correct, nothing but option 1 is going to follow. Moving on to 31st question, consider the declaration static char hello. The output of printf %s/n hello will be the same as that of puts of hello printf %s/n hello puts hello/n. You can declare either A or C, or you can declare like D also, nothing but option 4 is going to follow. Let x be an array which of the following are illegal operation. ++x is an illegal operation, and x++ is an illegal operation. X into 2 is an illegal operation. You can perform x+1, right? So statement A, C, D is going to follow, nothing but option 3 is correct. They are asking for illegal. Moving on to 33rd question, for obtaining an VSWR, which of the following statements are given? If VSWR equals to infinite, then there is a perfectly mismatch. Now VSWR nothing but rho equals to infinite, which is equals to 1 plus mod gamma divided by 1 minus mod gamma. This is reflection coefficient. So what I'll be getting is 1 minus of mod gamma, I'll be getting 0. So I'll be getting gamma equals to 1, which is for perfectly mismatched. If reflection coefficient equals to 0, then you'll not be getting reflection, but they are telling perfectly mismatched. This statement is false. You will be having a successive maxima and successive minima. So maxima and minima is separated by a distance of maxima to maxima and minima to minima. The distance separation is lambda divided by 2, but maxima to minima and minima to maxima, the distance separation is lambda divided by 4. So these things you have to remember. So based on this, if I am choosing, I'll be getting option 2 as correct. 34th question, in a dominant mode in a rectangular waveguide, following statements are given. There will be no any attenuation they are asking, but there will be an attenuation. There is no TEM mode propagation. Yes, there is no magnetic field component. There will be a magnetic field component. The dominant mode shows the highest cutoff wavelength and lowest cutoff frequency. So this statement is also true, nothing but B and D is going to follow, that is option 2 is correct. 35th question, read the following statement and choose the correct one. Industrial noise is usually of impulse type. This statement is false. High frequency mixers are generally noisier than high frequency amplifiers. This statement is correct. Thermal noise is independent of the frequency at which it is measured. True. Impulse noise voltage is independent of the bandwidth term, nothing but option 3 is going to follow. 36th question, read the following statements regarding advantages of SSB over DSB and full carrier AM, nothing but a simple AM they are talking. First statement what they are given is, in SSB more channel space is required. Yes, it's a true statement. The transmitting circuit of SSB is more stable, they are telling. It is not stable. The SSB signal is more noise resistance. Yes, SSB needs less power for the same signal strength. Yes. If I am talking about percentage power saving in the case of SSB, what I will be getting is carrier power I will be saving, and one of the sideband power I will be saving, that is upper sideband, or I will be saving the lower sideband, whole divided by carrier power plus upper sideband power plus lower sideband power. So the corresponding option that is going to follow is option 4 is correct. In an SCR, the following statements are given. First statement what they are given is, it acts as a short circuit device. Yes, it acts as a short circuit device. It acts as an open circuit device, they are telling. It is wrong. On voltage is approximately 2 to 5 volts. Yes, and they are telling 50 to 100 volts. This statement is wrong. The characteristic curve in the case of SCR, what you will be getting is, you will be getting something like this. So this is your forward blocking voltage. So beyond this, if you are applying the voltage, then the voltage drop will be approximately 2 to 5 volts. So in order to reduce this huge forward blocking voltage, which is of hundreds of volts, what you are going to do is you are going to inject gate pulses. So in order to reduce the forward blocking voltage. So the suitable option that is going to follow is statement 2 is correct. 38th question, photodiode can be used as a detector in forward bias is wrong, a detector in reverse bias is correct. It can be used as a light dependent resistor is a true statement. It generates solar energy is wrong. What photodiode is going to do is it is going to convert light energy into electrical energy. So statement B and C is correct, nothing but option 2 is going to follow. 39th question, read the following statements. The first statement what they are given is stability is a performance measure of a system. It's true. A system is stable if all the poles of the transfer function have positive real part is wrong. It should be in a negative real part. A system is stable if all zeros of the transfer function have negative real part. Stability is defined in terms of poles, not with respect to zeros. If you are having all the poles on the left half of a plane, then that kind of system is called as minimal system. It is also called as minimum phase system. So the suitable option that is going to follow is option 4 is correct. 40th question, the transfer function provides complete insight into the structure of the system. It is not going to provide the complete insight. It offers a symbolic picture about the dynamic characteristics of the system. This statement is correct. What statement C is telling is it does not give any insight into the structure of the system. This statement is correct. What statement 4 they are telling is if the transfer function of individual components of the system is known, the overall transfer function or the overall characteristics of the system can be determined by just taking their product. This statement is false. If two blocks are connected in series, then the overall transfer function is given by the product of the individual transfer function that is taken together. So we will be getting statement B and C is correct, nothing but option 2 is going to follow. For the first question, you have to match the following. On the list 1 they have given lift off, dry etching, lithography and diffusion. We know that lithography is PMMA, nothing but polymethyl methacrylate. And next, you are familiar with respect to dry etching also. Dry etching is bombardment of plasma. Next, if I am talking about diffusion, diffusion is Fick's equation and lift off is structures of targeting material on surface of substrate. So the corresponding option that is going to follow is option 1 is correct. For the second question, on the list 1 they have talked about various types of damping, and on the list 2 they have given the damping factor, that is zeta. So in the case of underdamped system, zeta should be less than 1, and in the case of critical damped system, zeta should be equals to 1. Quality factor is given by 1 divided by 2 zeta. Overdamped is given by zeta greater than 1. Quality factor Q equals to 1 divided by 2 times of zeta, which is equals to 1 divided by R into root of L divided by C, and zeta equals to R divided by 2 into under root of C by L. So the corresponding option that is going to follow is option 3 is correct. For the third question, match the following. On the list 1 they have talked about logarithmic amplifier, and the second one is a stable multivibrator circuit, and the third one is inverting configuration, and the fourth one is differentiator because you are having capacitor over here. So you can map this inverter as this option because you will be getting a phase shift of 180 degree. The formula is minus RF divided by R1 times of V in. And differentiation means a triangular waveform means you will be getting a square waveform or a rectangular waveform. Logarithmic amplifier, it is the curve will be something like this because you will be having a forward voltage drop of Vt. That Vt is this voltage. Able to follow? Next, you will be having an unstable vibrator circuit. So for this option is correct. So the suitable option that is going to follow is option A is correct. For the fourth question, match the following. In the case of minimization, you are going for K-map or Quinn-McCluskey method, and the second one is successive approximation register type. It is a type of A to D converters. You will be having 4 types of A to D converter. First one is counter type, second one is flash converter or flash type, third one is successive approximation register type, fourth one is dual slope or integrating type. Data selector is multiplexer and sequence generator is shifter. So for this, the option that is going to follow is option 2 is correct. 45th question, match the following. In the case of 8085, ground is which pin? Reset, RD bar, VCC. None of the pins are getting matched. Ground pin is pin number 20 and reset nothing but reset in bar. Pin number is 36 and RD bar, the pin number is 31 and VCC is pin number 40. Nothing but none of the option is getting matched. Again, this question is a grace question. 46th question, ternary operator means you will be having 3 arguments and array means it's a substring, nothing but similar data items. Continue, it is unconditional branch, structure is a heterogeneous, so the suitable option that is going to follow is option 4 is correct. 47th question, return loss. Return loss is 10 log of Pi divided by PR. Insertion loss, it is 10 log of Pi divided by P0 and transmission loss, it is 10 log of Pi divided by Pi minus PR and the reflection loss, it is 10 log of Pi minus PR divided by P0. You should know the term what do you mean by return loss, insertion loss, transmission loss and reflection loss. So the suitable option that is going to follow is option 4. 48th question, on the list 1 they have talked about coherent PSK, coherent FSK, non-coherent DPSK and non-coherent FSK. So you have to match the appropriate answers. So the corresponding option that is going to follow is option 4 is correct. Straight away you have to remember the direct formula. 49th question, on the list 1 they have talked about UJT, nothing but unijunction transistor. You have to talk about intrinsic standoff ratio which is denoted by eta. Always eta should be less than or equals to 1. In the case of UJT, it is also called as relaxation oscillator. You will be having negative resistance. Also, negative resistance will be there in tunnel diode. Silicon control rectifier, you will be having 2 currents. One is latching current and the second one is holding current. Diac is a bidirectional switch. The symbol for diac will be something like this. So you will not be having gate pulses in the case of DAC, but in the case of SCR and in the case of track, you will be having the gate pulses. Even in GTO also you will be having the gate pulses. For McMurray, inverter. So the suitable option that is going to follow is option 3 is correct. 50th question, 1 divided by S minus alpha, where you are going to place on the right side. 1 divided by S plus alpha, you are going to place on the left side, because how you are going to represent is 1 divided by S minus alpha. It is plus alpha. So it is on the right side. Second statement is 1 divided by S minus of minus alpha. So this pole is at minus alpha. Able to follow? On the numerator you are going to represent zeros. On the denominator you are going to represent poles. 1 divided by S minus alpha the whole square plus omega naught square is this option. 1 divided by S plus alpha the whole square plus omega naught square, this option. So the suitable option that is going to follow is option number 4 is correct. Arrange the below mentioned diodes in order of the increasing doping concentration. First one they have talked about avalanche diode, nothing but pin diode, and the second one is normal diode, the third one is tunnel diode, and the fourth one is Zener diode. We know that in the case of tunnel diode you are going to dope heavily, nothing but it is P++, N++, but in the case of Zener diode it is P plus configuration and N plus configuration. In the normal diode it is a PN, but in the case of avalanche diode you are going to make use of P intrinsic layer followed by N. So normal diode will be doped normally. In the case of avalanche diode you will be having a depletion layer over here which is lightly doped. So first should be avalanche diode, followed by it should be normal diode, then it should be Zener diode, then it should be a tunnel diode. Nothing but ABDC should be correct, but UGCNET board they have opted for BADC. 52nd question. A 20 ohm resistor is connected in series with an inductor, a capacitor and an ammeter across a 25 volts variable frequency supply. when the frequency is 400 Hertz, the current attains its maximum, that is 0.5 amperes, and the potential difference across the capacitor is 150 volts. Now look at over here, what they have given is a resistor is connected in series with an inductor and a capacitor, and you will be having an ammeter across 25 volts, and the frequency is 400 Hertz. The current attains a maximum at 0.5 amperes. So the current is going to reach a maximum value of 0.5 amperes. The potential difference across the capacitor, they are telling it is 150 volts. When current will be maximum in the case of RLC circuit means when it is reaching a resonance. At resonance, you will be getting inductive reactance which is equals to capacitive reactance. So same voltage drop will be across inductor as well as capacitor. So how we are going to find is XL, how I can express it is 2 pi times of FL, which is equals to 1 divided by 2 pi times of FC. So I will be getting LC equals to 0.158 micro. So I have to do a trial and error method. So I will be getting the value of C, which is equals to 1.325 microfarad, and the value of L is 0.119 Henry. One more method how to solve this problem. Let me call this 0.5 amperes is flowing through all the elements equally, nothing but the current in the inductor is also 0.5 amperes and the current into the capacitor is also 0.5 amperes. Now how can I write VC? VC equals to current multiplied by capacitive reactance, that is XC. What is the value of VC? It is 150, which is equals to 0.5 amperes multiplied by, how can I write XC? XC equals to 1 divided by omega C, which is equals to 1 divided by 2 pi FC. What is the value of F? It is 400 into C. So I have to calculate the value of C, that is 1.325 microfarads. 1.325 microfarads. Similarly, what is the value of XL times of I? That is VL. So VL equals to 150 volts, which is equals to current is 0.5 into what is XL? It is 2 pi times of FL. What is F? It is 400 into L. So I will be getting the value of L as 0.119 Henry. So two ways are there in order to solve the problem. The first way is easy. 53rd question, arrange the below referred amplifiers in the decreasing order of input impedance. So first one what they have given is common base amplifier, second one is common emitter configuration, third one is common collector configuration, fourth one is op-amp. They are asking us to arrange in decreasing order. First one is op-amp because the input impedance in the case of op-amp is very high when compared to all these three configuration. Next comes common collector configuration which is high, and next comes is common emitter configuration where input impedance is a moderate value, and last one is common base configuration where input impedance is a very low value. But if I am talking about output impedance, then common base configuration will be having high, common emitter moderate, common collector very low value, op-amp it is of the order of 50 ohms to 75 ohms. So the suitable option that is going to follow is option 3 is correct. For a logic family, they have talked about VOH, VOL, VIH and VIL. Now look at over here, one circuit is driving another circuit. At that time you need to talk about noise margin, nothing but you have to give some grace in terms of noise margin. So this level is VOH and next level is VIH and this level is VIL and this level is VOL. Based on this, if I am choosing, I will be getting option 2 as correct. 55th question, in 8257 DMA controller, the content of bits A15 RD which is equals to 0 and A14 that is WR nothing but right pin which is equals to 1 of the terminal count register indicate. So it is going to indicate a read cycle in memory mapped as well as write cycle in IO mapped, nothing but option 3 is going to follow. Following are the arithmetic operations in C. We know that if I am talking about the priority, addition sign and subtraction will be given equal priority. Multiplication, division as well as modulus will be given the equal priority. But among this I'll be getting the first priority for this one, and second priority will be given for addition and subtraction. So modulus should be given the highest priority. Modulus should be given the highest priority, followed by this statement is again wrong. They are telling it's increment followed by binary plus and unary minus. We know that first priority should be given for brackets, then priority should be given for arithmetic operator, then it will be given for logical and relational operators. At last it will be for increment and decrement operators, then followed by it is assignment operators. So here none of the option is getting followed. Following are the microwave bands. They are asking us to arrange in the increasing order of the frequencies. So how to remember is, you will be having a band of frequencies. So how to remember is LS, C, X, Q, K, K followed by sub-millimeter band. Followed by sub-millimeter band, nothing but option 4 is going to follow. 58 question, consider the following probability density function of a random variable x. They have given f1 of x, f2 of x, f3 of x. Arrange the above function in terms of increasing value of mean of random variable, that is x. We know that expectation of x nothing but e of x, which is given by integral minus infinity to plus infinity x times of f of x dx. So based on this, if I am solving, for first one I will be getting 0, for second one I will be getting 1 by 3, for the third one I will be getting minus 2 by 3. If I want to arrange in increasing order, the sequence should be C, A, B, nothing but none of the option is going to follow. So this is the Gray's question. Following are the semiconductor materials that are given below. They are telling us to arrange in the increasing order of the band gap. We know that in the case of silicon, the band gap is 1.121 electron volts. In the case of germanium, it is 0.72 electron volts. But in the case of gallium phosphide, it is 2.24 electron volt. But in the case of gallium arsenide, it is 1.47 electron volt. Nothing but option 1 is going to follow. Nothing but first it should be germanium, last one it should be gallium phosphide. Moving on to 60th question, they are asking, above they have given the following circuits. You have to arrange the above circuit elements in the decreasing number of total number of poles and zeros you have to arrange. We know that in the first case, the transfer function is given by 1 divided by 1 plus SCR, nothing but you will be having only one pole and you will not be having any zeros. But if I am talking about the case 2, you will be having the transfer function which is given by S square times of C2 into R2 into C1 R1 plus S times of C1 into R1 plus S times of C2 whole divided by S square times of C2 into C1 into R1 plus S times of C2, nothing but you will be having two poles. Similarly, for the second case, the transfer function is given by R2 into 1 plus SC R1 divided by S times of R1 R2 into C plus R1. So how I got the transfer function? I will be sharing the PDF file. So here also I will be getting only one pole. I got only one pole, but I got 1 0 also. But in the third case, I got 2 poles and 2 zeros. So the suitable option that is going to follow is option number 4 is correct. Moving on to 61st question, assertion and reasoning based questions. Assertion, what it says is, when a varactor diode is connected to an inductor L in a resonant circuit, the frequency is varied with respect to the voltage that is applied across the varactor. Yes, you will be having a varactor diode that is shown over here. Based on the applied voltage, if you are changing the voltage, the capacitance across it will get changed. So in the case of resonant circuit, that is FR equals to 1 divided by 2 pi root LC, you are not going to vary the inductor because it is very much bulky. So inductor you are going to make it as a fixed parameter, but you are going to vary the capacitance. Tuning physical capacitance is very much difficult. So what you are going to do is you are going to make use of a varactor diode. So assertion is correct. But what the reason they are telling is, because the PN junction used is hetero type and abrupt PN junction. This statement is also true, but reason is not giving the proper explanation for assertion. So I have to opt for B. Nothing but both assertion and reason is correct, but it is not giving the proper explanation for assertion. Moving on to 62nd question, Laplace and Z transforms can be applied to the analysis of many unstable systems and consequently play an important role in the investigation of the stability or instability of the system. This statement is true case, but what the reason they are telling is the region of convergence of the Laplace transform of x of t is given by x of t into e power of minus st, where s equals to sigma plus j omega, but they have given only sigma, so this statement is. So I need to opt for C, nothing but only assertion is correct but reason is false. Moving on to 63rd question, what they have given is a small signal amplifier is one where the input voltage is sufficiently small and change in output current is only small fraction of the mean output current. So this statement is a true case, but what the reason they are telling is several stages of small signal amplifiers are therefore coupled together in a cascade. This is false. So assertion is correct but reason is false. So I need to opt for option C. 64th question is based on total pole concept. What they are given is in the figure shown below, output is I state, Q3 acts as emitter follower or common collector configuration with its associated low output impedance. Yes, it is having low output impedance. This low output impedance provides a small time constant for charging up any capacitive load as the output, and this is called as active pull-up, and this action is called as active pull-up, and it provides very fast rise time waveform at TTL totem pole output. Yes, this statement is correct, but what is the reason they are telling is totem pole outputs cannot be wire-ANDed, that is outputs of a number of gates cannot be tied together to obtain AND operation of those outputs. Even reason is also correct, but reason is not making any explanation with respect to assertion, because here assertion they are talking about common collector configuration and they are talking about capacitive load, but what the reason they are talking is they are talking about AND operations that are tied together, nothing but they are talking about the output node. So assertion is correct, reason is correct, but reason is not giving the proper explanation for assertion, so I need to opt for B. Moving on to 65th question, the data bus of a microprocessor is used to transfer information between the microprocessor and memory, between the microprocessor and I/O device. Yes, this statement is correct. The data bus of a microprocessor is unidirectional. This is wrong. Actually, it is bidirectional. So in the case of microprocessor 8086, data bus is of 16-bit wide, but if I am talking about 8085, it is 8-bit wide, but if I am talking about microcontroller 8051, the data bus is of 8-bit wide, and the address bus is of 16-bit wide in the case of microcontroller 8051, also microprocessor 8085, but if I am talking about 8086, the address bus is of 20-bit wide. So assertion is correct, but reason is false, so I need to opt for option C. Moving on to 66th question, unless we call init graph, we cannot draw anything on the screen. This statement is correct, nothing but assertion is correct. What the reason they are telling is any shape drawn on the screen can be animated using the function get image and put image. Even this statement is also correct, but reason is giving the proper explanation for assertion, so I need to opt for A. Unless I call init, I can't draw any waveform. So in order to draw the waveform, I need to make use of a function that is get image and put image. 67th question, what they are telling is circular polarization is a special case of elliptical polarization. In the case of circular polarization, the amplitudes nothing but A equals to B and the phase will be having a 90-degree variation. But if I am talking about elliptical polarization, A is not equals to B, as well as phase can be equals to 0, but it should not be equals to 90-degree. Nothing but 90-degree phase variation should not be. So assertion is correct, but what the reason they are specifying is in elliptical polarization, the wave will be having two components. One is transverse in x direction and other is traveling in y direction, which causes the electric field to rotate as a function of time. Yes, it's a true statement. Even reason is also giving the proper explanation for assertion, because they have talked about two components which is going to cause an electric vector to rotate as a function of time. Nothing but wave will be propagating as a function of time. Electric fields and magnetic fields are perpendicular to each other. Nothing but option A is going to follow. 68th question, as compared to PWM, PAM, PPM, PCM is much better for noise immunity, they are telling. Yes, it's a true statement, But what the reason they are telling is PCM depends only on the presence or absence of the pulses at any given time, not on the characteristics of the pulses, which could be distorted. Even this statement is also correct. Reason is giving proper explanation for assertion, so I need to opt for A. 69th question, light is electromagnetic wave in nature. True. These may be X-rays, radio waves and even microwaves also. Yes. What the reason they are telling is the amount of energy depends on intensity of the light rays. The energy associated with each photon is directly proportional to the frequency. Reason is also correct, but it is not giving the proper explanation for assertion. 78th question, what they are telling is the dynamics of a system can be represented by a series of first order differential equation. This is based on control system definition. Yes, it's correct. The state variables describe the future response of the system given the present state, the excitation input and the equation describing the dynamics. Even reason is also correct. Also reason is giving the proper explanation for assertion, so I need to opt for option A. Pause this video and go through the theory behind this. So with the help of this theory, you need to answer question number 71 to question number 75. This question is based on the family of microprocessor, so you need to go through. Moving on to 71st question, in 8085, if the clock frequency is 5 MHz, then what is the time required to execute an instruction that is having 18 T states? So in order to execute 1 T state, it is going to make use of 1 divided by F clock, nothing but it is going to take 0.2 microseconds. So if I want to execute an instruction which is going to take 18 T states, it requires 18 multiplied by 0.2 micro, which is equals to 3.6 microseconds, nothing but option 2 is going to follow. Moving on to 72nd question, in microprocessor 8085, the values of the most significant bit of the result shows the execution of any arithmetic or boolean instruction and is stored in sign status flag, which is going to denote whether the number is positive or negative. So the suitable option that is going to follow is option A. Moving on to 73rd question, what they are given is push B in the case of 8085 microprocessor, what it is going to do. First option what they have given is the contents of register B will be copied into the stack. It's wrong. The contents of register B and C will be transferred to the stack and the register gets cleared. They are telling it is wrong. The contents of the register, that is B and C, will be copied onto the stack. It's a true statement. B and C is going to get cleared. This is false. You will be having a register pair, that is BC, DE, HL. So these are all three register pair. Whenever you are performing push B, B and C is going to push onto the stack. Whenever you are performing push D, D and D register value will be pushed to stack. So these things you should know. So the corresponding option that is going to follow is option 3 is correct. 74th question, the technique of assigning a memory address to each IO device in the computer system is called. It is called as memory mapped IO. So you are having two variants. The first one is memory mapped IO and IO mapped IO. So in the case of memory mapped IO, each and every memory storage you are going to treat it as an internal storage and then you are going to solve. But in the case of IO mapped IO, you will be having separate address bus, nothing but 8-bit address bus you are going to dedicate. So the suitable option that is going to follow is option 4. 75th question, which instruction cannot force the 8086 microprocessor to come out of alt state? That is nothing but hold state. So hold instruction cannot force 8086 to come out of alt state, nothing but option 4 is going to follow. For an N-channel MOSFET shown in the figure below, the threshold voltage VTH equals to 2 volts. So they have given the threshold voltage which is equals to 2 volts and the drain current of a MOSFET is 4 milliamperes. So in the first case they have given drain current ID equals to 4 milliamperes and the drain resistance RD which is equals to 1 kilo ohms. If the value of RD is increased to 4 kilo ohms, nothing but RD dash, I am going to take it as 4 kilo ohm. They are asking what is the value of ID. They are asking what is the value of ID, that is ID dash. Whenever gate terminal is shorted to drain terminal, at that time you will be having a potential of VDS which is equals to VGS. At this time transistor will be operating in saturation region. transistor is operating in saturation region. Now what is the drain current expression in the case of saturation region? We know that the drain current ID equals to mu n Cox W by L into VGS minus VTH the whole square whole divided by 2. This is the expression for drain current in saturation region. They have not talked about mu n Cox W by L, where W by L is the aspect ratio. So I am going to treat this entire expression value as, say, some constant. I am going to call it as a beta. So ID equals to beta times of VGS minus VTH the whole square. Call it as equation star. Now in the first case, what is the value of ID? So ID equals to 4 milli, which is equals to beta into what is the value of VGS? How can I write VGS? VGS equals to VG minus VS, but we know VS equals to 0. So I'll be getting VG minus VTH. VG minus, what is the value of VTH? It is 2, the whole square. So I'll be getting 4 milli, which is equals to beta into, how can I find out the value that is VG? VG is same as VD. So I'll be getting VD equals to, so I'll be getting VD equals to 10 minus of ID times of RD. 10 minus of ID times of RD. So what is the value of ID? It is 4 milli multiplied by, what is the value of RD? It is 1 kilo minus 2 the whole square. So I'll be getting 4 milli, which is equals to beta into, what is milli and kilo? Milli and kilo is going to get cancelled. 10 minus 4 is 6. 6 minus 2 will be 4. So I'll be getting 4 square. So finally I got beta equals to 1 milli divided by 4. So I got beta equals to 1 milli divided by 4. Now look at over here. Let me substitute in the second case. So I got ID dash, which is equals to beta into, what is VG? VG is 10 minus of ID dash into, what is the value of RD dash? It is 4 kilo. Kilo and milli, anyway it is going to get cancelled, minus 2 the whole square. So I got ID dash, which is equals to milli divided by 4 into, what is 10 minus 2? It is 8. 8 minus 4 ID dash square. So I got 4 ID dash, which is equals to milli into 8 8s are 64 plus 16 ID dash square minus 8 4s are 32. 32 times of 2 will be 64 times of ID dash. So I'll be getting, anyway current is in the order of milliamperes. So I got 16 times of ID dash square minus 68 times of ID dash plus 64, which is equals to 0. So on solving with the help of minus b plus or minus under root of b square minus 4ac whole divided by 2a, I'll be getting the value of ID current, that is ID dash, which is equals to 2.804 milliamperes, and one more current is 1.402 milliamperes. Out of this, 1.402 is correct, 2.804 is wrong. On what basis I can tell this value is wrong? Because if I am substituting the value of ID dash over here, what I will be getting is 2.8 multiplied by 4 will be greater than 10. Voltage drop can't exceed 10 volts. So I need to opt for 1.402, nothing but option C is going to follow. To the best of my knowledge, I have provided the solution of all 75 questions. If you followed it my lecture, please give it a big thumbs up. Also share this video with your friends. To watch more and more videos on previous year solved paper, please subscribe to my channel and don't forget to turn on the bell icon to get instant notification whenever I upload a new video. Thank you. All the best for your exams.